Welcome to solverfy.
For this problem on the topic of oscillators, we are asked to draw a graph for the energy versus displacement for a horizontal spring, which has a spring constant of 95 Newton per meter and a mass of 55 grams at the end of it. If we assume the spring was started with an initial amplitude of 2 centimeters, then we are asked to calculate the potential energy, the kinetic energy, and the speed of the mass for x is equal to 1.5 centimeters, all from the graph. Now, we have drawn the graph already for the energy versus displacement, and we can see that the total energy, which is shown as 0.019 joules, can be found as follows. So this energy E, the maximum energy, is a half Ka squared, which is the maximum elastic potential energy, and that's a half times the spring constant K, which is 95 newtons per meter, times the amplitude of oscillation 0.02 meters squared, which gives us this energy 0.019 joules, which is the horizontal line drawn on the graph. Now, if we go to the graph, we need to first find the potential energy at x is equal to 1.5 centimeters. And we can see that at this point, at 1.5 centimeters, we get the potential energy U to simply be 0.011 joules. So we can read that off from the graph. Now, for part B, we can use energy conservation at x is equal to 1.5 centimeters, and we get the kinetic energy is simply the total energy calculated above, E, minus the potential energy U at that point. And so that's 0.019 joules minus 0.011 joules, which gives us the kinetic energy to be 0.008 joules. So the remaining that isn't potential energy is kinetic energy. Now lastly, we want to find the speed of the mass at this point. Now we can find the speed from the estimated kinetic energy, since we know the kinetic energy K is equal to a half mv squared. This means that the speed v is the square root of 2k over m, which is the square root of 2 times 0.008 joules over the mass of 55 grams, which is 0.055 kg. Calculating, we get the speed of the mass at 1.5 centimeters to be 0.5 meters per second.